Have you ever wondered if time travel is possible? What if we could revisit the past or leap into the future? NASA has been exploring that very possibility. According to NASA, time travel is possible through the concept of time dilation, which is a key component of Albert Einstein's theory of relativity. Einstein's theory of special relativity states that time and space are intertwined, and the speed of light is an unbreakable cosmic speed limit. Einstein, in his theory of special relativity, determined that the laws of physics are the same for all non-accelerating observers, and he showed that the speed of light within a vacuum is the same no matter how fast an observer is traveling. As a result, he found that space and time were interwoven into a single continuum known as space-time, and events that occur at the same time for one observer could occur at various times for another. Time travel is not without its paradoxes. The grandfather paradox, for instance, is a classic conundrum. Imagine going back in time and accidentally causing the demise of your own grandfather before your parents were born. This would mean you were never born, but then, who traveled back in time to cause the accident? A mind-twisting loop, isn't it? Then there's the bootstrap paradox. It's a scenario where an object or piece of information sent back in time becomes trapped within an infinite cause-effect loop. Think of a man who receives a book from his future self, learns from it, and then eventually sends the same book back to his younger self. The question then arises, where did the book originate? These paradoxes pose fascinating challenges to our understanding of time and causality. They question the linearity of time and make us wonder if the past, present, and future can indeed intertwine in complex and unimaginable ways. As overwhelming as these paradoxes may seem, they haven't stopped scientists from exploring the possibility of time travel. The concept of time travel isn't just confined to the realm of fiction. Some of the greatest minds in science have laid the theoretical groundwork for it. Let's start with the most famous scientist of all time, Albert Einstein. His revolutionary theory of relativity, first proposed in the early 20th century, completely changed the way we understand space and time. You see, according to Einstein, space and time aren't separate entities, but rather, they're woven together into a four-dimensional fabric known as space-time. Now here's where things get interesting. Einstein theorized that the fabric of space-time could be warped by mass and energy, leading to the phenomena of time dilation. In essence, time dilation means that time can run at different rates for two observers, depending on their relative motion or the strength of their local gravitational field. To put it simply, if you were to travel near the speed of light or hang out near a massive object, your watch would tick more slowly than the watches of those left behind. While the concept of time dilation might seem like something straight out of a science fiction novel, it has been experimentally confirmed numerous times. For instance, atomic clocks flown in high-speed aircraft or placed on tall mountains have been shown to run slower than their counterparts at sea level. But the concept of time travel isn't without its paradoxes and quandaries. Enter Stephen Hawking, another giant in the world of theoretical physics. Hawking proposed the chronology protection conjecture, which posits that the laws of physics prevent time travel to the past on any significant scale. According to Hawking, this is a good thing, because it prevents all sorts of bizarre paradoxes, like the possibility of going back in time and preventing your own birth. These early theories provided a glimpse into the potential of time travel, but turning theory into reality is another matter entirely. While time travel remains largely theoretical, NASA has been making strides that could bring us closer to this once impossible dream. In the vast expanse of the cosmos, NASA's scientists have been exploring the potential of wormholes as shortcuts through spacetime. Wormholes, in theory, are tunnels through the fabric of spacetime, potentially linking disparate points across the universe. Imagine folding a piece of paper in half to bring two distant points closer together. That's how a wormhole works, but with the paper being the universe itself. However, the challenges in creating and stabilizing wormholes are immense. First, we need to understand that wormholes are predictions from Einstein's theory of general relativity, but they are yet to be observed directly. So the first challenge is to confirm their existence. NASA's scientists are using innovative technology and innovative ideas to detect these elusive phenomena. The next challenge is creating a wormhole. This would require a type of matter with negative energy density. Now this might sound like something out of a science fiction novel, but it's a real concept in quantum physics. However, creating or finding this matter is a monumental task. Then comes the task of stabilizing a wormhole. You see, wormholes, according to current theoretical understanding, are highly unstable. They might collapse in the blink of an eye. Stabilizing them would require an enormous amount of this negative energy density matter. And even if we manage to create and stabilize a wormhole, there's the question of safety. Could a human being travel through it without being torn apart by gravitational forces? Despite these challenges, NASA's researchers remain optimistic. They're pushing the boundaries of our understanding of the universe, and who knows? One day, their efforts will lead to a breakthrough that allows us to travel through time and space in ways we can only dream of now. The quest to master wormholes is just one of the ways NASA is pushing the boundaries of our understanding of time and space. To reach the distant corners of the universe, or possibly even different times, we need to rethink our approach to space travel. And that's where advanced propulsion systems come into play. They are the engines that could take us to the stars and beyond. The importance of these systems cannot be overstated. Our current space travel methods are simply not sufficient for the kind of deep space exploration we are envisioning. We need to travel faster, further, and more efficiently. That's where advancements in propulsion technology become crucial. NASA, along with other organizations, is investing significant resources into the research and development of these systems. Two potential propulsion technologies that have been garnering attention are nuclear thermal propulsion and ion propulsion. Let's start with nuclear thermal propulsion. This technology works by heating a liquid propellant using nuclear fission to create thrust. It's a rocket engine that uses a nuclear reactor to heat up its fuel, creating a forceful expulsion of gases that propels the spacecraft forward. Ultra-safe nuclear technologies, for instance, has developed a design concept for a rocket engine using this technology. It could potentially reduce travel time to Mars by up to 25%. But as with any groundbreaking technology, there are challenges. Finding uranium fuel that can withstand elevated temperatures and addressing radiation concerns are some of the hurdles that need to be overcome. Then there's ion propulsion. This system uses electricity to expel plasma, generating thrust. It's more efficient and faster than traditional chemical rockets. Ion propulsion could be the answer to the long-duration space missions of the future. The technology is not entirely new. It has been used in some space missions already. But NASA is working on developing this technology further, making it more reliable and efficient for longer, more ambitious missions. These technologies are not just theoretical. They are being actively researched, tested, and refined. The goal is not just to make them work, but to make them work well enough and safely enough to be used in real-world space missions. The potential this advanced propulsion systems hold is immense. Reduced travel times, increased mission durations, and the ability to reach previously unreachable destinations are just some of the possibilities. We're not just talking about going to Mars or the outer planets. We're talking about going to other stars, other galaxies, even other times. These advanced propulsion systems could revolutionize space travel as we know it. They could make the concept of interstellar travel a reality. And who knows, even time travel. Advanced propulsion systems may well be the key to unlocking the potential of interstellar and possibly even time travel. As we consider the future of space and possibly time travel, one private company stands out: SpaceX. This private entity, founded by Elon Musk, isn't just making waves, it's making history. With its groundbreaking work on the Starship vehicle, SpaceX is redefining our understanding of space travel's potential. The Starship vehicle is more than just a spaceship. It's a testament to the power of innovation and the spirit of exploration. This vehicle, more powerful than any rocket flown before, is designed to carry humans and cargo to destinations in our solar system and potentially beyond. Its development has been an adventurous journey, with testing including hop tests and high-altitude flights, some of which ended in spectacular explosions. But such is the path of progress. With each mishap, SpaceX has refined its design, turning setbacks into stepping stones. The Starship's power lies in its innovative design and innovative technology. It's being built to be reusable, reducing the cost of space travel and making it more accessible. But the truly momentous change is its propulsion system. Unlike traditional rockets that use chemical propulsion, Starship's engines are designed to be more efficient and robust, potentially enabling longer and faster voyages. And when we talk about long voyages, Mars is the most immediate goal. With a round-trip Mars mission expected to take approximately 3 years, advancements in spacecraft propulsion are needed to reduce travel time and radiation exposure for astronauts. This is where the Starship steps in. Its powerful engines could shorten the travel time, making Mars missions more feasible and safer for crew members. But SpaceX's ambitions don't stop at Mars. With Starship's powerful propulsion and large payload capacity, destinations farther in our solar system and even interstellar travel become more than just a dream. This opens a myriad of possibilities for exploration and discovery, and brings us closer to understanding the mysteries of our universe. Not only is SpaceX pushing the boundaries of space travel with the Starship, but it's also playing a crucial role in NASA's ambitious plans for human exploration. SpaceX has a contract with NASA to use Starship for the Artemis program. This collaboration marks a significant shift in space exploration, with private sector companies playing an increasingly key role. In the quest for time travel, advanced propulsion systems like those in the Starship could be key. While we're still far from turning the concept of time travel from science fiction into science fact, these advancements bring us one step closer. The Starship's potential to reach far-off destinations in a shorter time could provide insights into the effects of space-time and open new avenues for research into time travel. SpaceX's ambitious projects may bring us one step closer to making time travel a reality. As we look to the future, the Starship stands as a beacon of hope, symbolizing our unending quest for knowledge and our relentless pursuit of the impossible. As we stand on the precipice of a new era in space exploration, the possibility of time travel seems less like science fiction and more like a scientific possibility. This statement could not be truer. The advancements we've witnessed in the past few years have not only challenged our perception of what's possible, but they have also brought us closer to the once far-fetched dream of time travel. But what does this mean for us, and what potential implications could time travel have on our reality? Imagine the ability to travel back in time and witness the Big Bang, the birth of our universe, or zooming forward to see the evolution of galaxies far beyond our own. Time travel could unlock the mysteries of our universe's history and its future. It could help us anticipate cosmic events, prepare for potential threats, and better understand our place in the cosmos. But beyond the thrill of exploration, time travel also presents a host of ethical and practical challenges. If we could change the past, what would stop us from altering the course of history? If we could foresee the future, how would that affect our decisions in the present? These are questions that we must grapple with as we venture into the unknown. On a more practical level, time travel would require an immense amount of energy. Even with advancements in propulsion technologies, we are still far from generating the kind of power needed to distort time. Moreover, the human body may not be able to withstand the physical stresses associated with time travel. These are just a few of the many hurdles that we need to overcome. Yet despite these challenges, the road to time travel is not without hope. The same spirit of innovation that propelled us to the moon and beyond is driving us towards this new frontier. Every day, scientists and engineers are working tirelessly, exploring innovative technologies, conducting experiments, and pushing the boundaries of what's possible. And who knows? One day we'll wake up to a world where time machines are as common as cars, where we can visit the past or future as easily as we travel from one city to another. But until that day comes, we must tread carefully, respecting the laws of physics and the ethical boundaries that guide us. We must continue to explore, innovate, and dream, for it is in this pursuit of knowledge that we find our true potential. Time travel, once a far-fetched dream, is now a tantalizing possibility. Only time will tell how far we can go.